Alright, today we'll be doing grade 12 physical sciences. We'll be specifically looking at paper 1, which is the physics part. Let everyone be greeted. I will be your tutor today. I'm Dr. Funza, and we'll be currently today looking at electrodynamics, which is a very interesting topic. It is sometimes hard to explain because the more you try to explain, the more it gets difficult for the students. So what I'm going to try and do here, I'm going to shorten the topics and make sure that you get everything that is necessary to know how to respond to the questions in electrodynamics. So it's a very interesting topic. It started in grade 11 in electromagnetism, which has the Faraday's law. So we are going to be looking at electrodynamics today. The word itself must be giving you an idea of what we are going to be talking about. So you can take a guess. Then from the first word we can see we have electro, which means comes from electricity. Then we have the word dynamics. We all know what dynamics means, motion, or just simply means movement. So what we are going to be doing basically today is to give you the insight and direct info on what is being asked in the exam. So we are not going to be broad, giving you things that are not going to be of any assistance to you. Everything that I'm going to be discussing with you, most of them will be the answers to the questions that they will be asked in the exam. So anything outside that, it is not going to be of any assistance to us. So we want to channel our focus into the things that we know for sure that those things are going to be into the exams. So let us get into it. I'm going to try and summarize the entire topic so that you can be able to have a full view on what this topic is all about. Now, as I have already stipulated there, that the first word has to do with electricity, the second word has to do with motion, meaning that there is a relationship between the electricity that is produced and the motion, like how our electricity is being generated. They take the motion of the water or the movement, the motion of wind. So they use wind to move the generators. So what we are going to be looking at here is this, which are the machines. Some they prefer to call them the electrical machines. So we are going to be looking at the two major types of electrical machines here, meaning that the other one is going to use electricity and convert it into the movement which is found in most of the toys that we are buying for our kids. Then the other one is going to take the motion, therefore convert it back into what? Into electricity, which are the generators that people are buying now because of our load shedding. So now let us look into it, meaning that these machines can be loaded into two ways. The first one, we are going to be looking at the generators. The generators. I believe it is not your first time you hear the word generator. You are used to that. We always say go and switch on the generator. What does the generator give us? Electrical energy. Alright. Now the second one, we are going to be looking at the motors. The motors, meaning that the ones that has to do with movement, a motor, the movement. So that is what we are going to be looking at. Alright, therefore, number one thing, guys, that you need to understand here is a basic thing, and is the inmost. The first question they ask you, can you identify what type of the machine is given? So in that case, You must be able to state whether you are having a generator or you are having a motor. And before the end of this session, you will be understanding all those particular things. Alright, now let us get into it. Number one thing that I need you to get into, it is the energy. The energy conversions. The energy conversions. The energy conversions. So in that case, I'm not sure about it. My feeling there, just check with me. The energy conversions. Let me create some space here. But the first thing that we need to look at, let me put it here so that we don't forget. Energy conversion. Conversion. The energy conversion. Perfect. There, thank God it is well placed. So in that case, the first thing that we need to understand, these two machines differ by what? By the energy conversions. Meaning that the first one, the generators, they are going to say, we are going to take the mechanical energy. So these machines takes the mechanical energy and then convert this energy into the electrical energy. Alright, so that is the energy conversion. Now, how are they going to ask you in relation to the energy conversion? The question will be like to you, state the energy conversion that is taking place in the machine. Then when you have to be able to tell us what. If it's a generator, tell us that it takes the mechanical energy, then convert it into electrical energy. Then now on this one, the vice versa is true, meaning that it is going to take what? Electrical energy. It is going to take electrical energy, then convert it to the mechanical energy. The mechanical energy. That is what you need to know. So that is our first differences between the motor as well as the generators. Number two, guys, these things that I am outlining here are exact things that I need you to bear in mind. The second thing is based on the principle. The principle. On which principle is this machine operating? The principle, remember we talked about the energy conversion. The second one, we need to look at what? At the principles. On which principle does this machine operate? Now, that question is going to come. You are going to see it. I can already see it in the exam there. Alright. So, the principle that you need to tell us then, it is the one that we did in grade 11, which is the Faraday's law. Meaning that the generators operate under the principle of Faraday's law. Some they prefer to call it the principle of electromagnetic induction. Electromagnetic induction. So, you can say this one operates under the principle of electromagnetic induction. These are from grade 11. This is a grade 11 stuff. So in grade 12, we are not going to ask you to state the Faraday's law or state the electromagnetic induction principle. We are just going to ask you, on which principle is this machine operating? Then you have to state. If it's a generator, you are going to tell us this principle operates under the Faraday's law or the principle of electromagnetic induction. That's it. No need to go further. You are now in grade 12. No need to know how to state the Faraday's law. You don't have to do that. Then on the motors, what do we need to know here? That this operates under the Lenz's law. Under the Lenz's law. So in that case, these are the two major principles that you need to differentiate these two machines. So now we are on number two things, and these things, guys, they do ask in the exam. They do ask this in the exam because we don't have a lot of calculations, meaning that the first portion of the question will be based on what we are saying. The second one will be based on the calculations. Alright, now let us get into it one more again. Now we know that the Faraday's law gives us the relationship between the current, the magnetic field, as well as the force or the rotation. Some they prefer to call it the rotation. So the relationship between these three things, it is the Faraday's law. So in that case, we know that this particular thing, it is operating based on the relationship of these three things, guys. The current, the magnetic field, as well as the force. The force, which is the one that is going to move the motors. So now, what we need to know here is the second part, the third part. They are going to ask you, how is the generators producing electricity? How is this producing the electrical current? That question, I like it so much because we know that it produces by the changing magnetic flux. By changing magnetic flux. We know that the magnetic flux is when you put an armature inside the magnetic field. When the armature rotates, the magnetic flux is going to be changing. So it is going to be changing, being the maximum, at the minimum, at all those things. But what we need to know here is that it produces electricity by the changing magnetic flux. So in that case, this is another important part that we need to know. Alright, now I've said this is based on three things. This is based on three things, or before I get onto that, we all know that the magnetic flux is given by the magnetic field multiplied by the area, then the cosine of theta. That is for grade 11. In grade 12, we are not going to be focusing on this much. But the reason I am writing that, I want to show you some that the magnetic field actually it is made by the magnetic flux is made by the magnetic field. The area is the area of the armature inside that magnetic field. Then the cosine of theta, this is the angle between the axis as well as the magnetic field. So the angle between the axis and the magnetic field. So if the angle is 90, then we are not going to be generating any magnetic flux. So that is why we are saying the changing magnetic flux. Alright. Therefore now, this one is a reminder from grade 11 that how can we increase the induced EMF, or how can we increase the current that is being produced. So number one that you can do is to increase the strength of the magnet. Let me not write those ones here because they are not going to ask that. By increasing the strength of the magnet, increasing the number of turns. Remember that the armature, when it's inside the magnetic field, if you increase the number of turns around the armature, the induced EMF or the current is going to be increased. Then if you increase the speed of rotation, this ones I'm giving you just for in case if it happens that you might need one. So let us now focus on those three. Increase the strength of the magnet, increase the number of turns around the armature, therefore increase the speed of rotation. So when that it is rotating fast, then you are going to be looking at the induced EMF increasing. Alright, then now bear in mind this is operating between these three things: the current, the magnetic field, as well as the force or the rotation. So in that case, these three things have relationship, and how are we going to be predicting the relationship between the generator and the motors? I'm going to show you this in not so long. In our generators, we are going to be predicting these three things using the right hand rule. The right hand rule. While on this one, we are going to be using the left hand rule. Alright, so in that case, these are the other things that we need to be looking at. Here, we are going to be using our right hand rule to predict the direction of the current, the direction of the magnetic field, as well as the direction of the force or the direction of the rotation. Let me write them down here for you. So this is going to be current, magnetic field, as well as rotation. Some they prefer to call it the force. I call it the rotation because the armature is rotating. So we use the right hand rule to predict the direction of the current if we are given the magnetic field direction and we know how the armature is rotating. We can predict the direction of the current. The same thing with the motors. We are going to be using the left hand rule. Alright. Then from there, let's see what else do we actually need to be talking about. Now, I'm going to be trying and explaining how the left hand rule is working and then how the right hand rule is going to be working. Let me erase here so that I can create some space for myself and for you to write. Alright, now I might be a little bit nervous here because this is my first video, but just bear with me. We are just going to be as fine as we can. Alright, therefore now, let me draw a simple generator here so that we can be able to see what I am talking about. Let me draw a simple generator here. Or before I show you how to use the right hand rule, let me focus on something which is very, very significant. This one, guys, is more important, which is the current that is being produced in the generators. It is going to be alternating. Meaning that when the armature rotates, we are going to have where the current is produced in one direction, then it changes the direction. So the induced current or the induced EMF, which gives us the current, is going to be alternating as the armature rotates. So that gives us a very, very important thing here. It gives us a very, very important thing. Now, when the current that is produced inside the generators, because of the rotation of the armature, it makes the current to do what? To change the direction. As the current is being produced, it changes the direction. So it does not travel in the same direction as we will anticipate. So as this is changing the direction, it gives us two major types of generators, and we must be able to state or identify. This is the AC generator. We are going to have an AC generator, and we are going to be having what we call a DC generator. We are going to have a DC generator. Alright. Now, don't even panic what a DC and what an AC is. You are still going to get them. Now, let us look at that. AC means alternate. We know, like in math, the alternating series and all those particular things. Alternating means that it is changing. To alternate means like it changing the direction. So in AC, meaning that the current is not moving in one direction, while in this one, the current is moving in one direction. Are we together, guys, there? So meaning here, this one is called a direct, this is called a direct current generator, or just in simple DC generator. This one is an alternating current. Just forgive me with my writing here, because I'm used to writing very, very fast. So we have the AC generator, we have the DC generator. Now, just for the safety purposes, I'm going to put that this one current moves in one direction. I know you already know that current moves in one direction. This one, I can say that the current is changing the direction. Current is changing the direction. So that is what you need to know. Alright, now because as the armature rotates, the current that is produced, it is changing the direction due to the changing magnetic flux in the magnetic field. So what differentiates these two generators? This is where most of the question lies. You must be able to look at the structure that it is given to you, and be able to tell what type of a generator do you have. Now bear in mind that now I'm no longer talking about the motors, I'm only focused on my two generators then, the DC as well as the AC generators. Alright, now let me draw a simple diagram of a generator. The generator must include one side of the magnet being north and the other side being south. So this is the magnet. The magnet is going to give us the magnetic field as I have already stipulated. Then what are we going to have again? I'm going to put in this wire, which is actually in that particular shape. Now, if you can see, we call this the armature. It is the one that is going to be rotating due to the magnetic field that is being produced by the magnet. Alright, then the same simple diagram of the AC generator, it is actually going to be the same here. I want you to spot the difference as I want to explain something here. Now just bear with me. Here my drawing is not that nice. Alright, now what differentiates these two generators is simple, guys. It's simple. It is the rings, the type of rings that are attached here, the types of rings that we attach on this particular end. Now, simple, on this one, we are going to have what we call the split rings. These are the split rings, commutators, and they prefer to call them the commutators. I just prefer simple things. This is the split rings. Sorry guys for that, there is a noise that is coming from outside, we cannot control that. Then again here, we are going to have what we call the split rings. We are going to have the split rings. Split, you know, if you split something, you are actually dividing it into two. Let me just you divide that into two. Now look at this here. These are the two generators. They look the same. I'm going to put in something that makes them to be different. Are we together there, guys? Alright. So, split rings, they are just a circle. They are just rings like that. Well, you might not be able to see them correctly here because of my drawings. Now, what you need to bear in mind here, guys, is very simple, is that the split rings are just a circle. It's a ring that is attached, is not divided anyhow. It is just like the finger ring. You can see that ring there. It is a circle, it does not have anything. And then now, on the split rings, we are going to have some smaller things there, which we are going to call them the brushes. These are the brushes, yes, the brushes. Now, if you check, the rings are not entirely, how do I put that? They are not they are not one piece, meaning that the rings and the brushes, what they do is that suppose this is the ring, this is going to be the brush. The brush is just going to touch the ring so that the current can flow from the ring to the brush. But the brush is not entered to this particular thing. I'm not sure if I use the correct term, but it is not attached, it is not one thing, meaning that the brush only touches so that the ring can rotate by itself without affecting the brush. So that is what I am trying to explain. Now, what are the functions or the purposes of these brushes? They can ask you that one. What are the functions of the brushes? Remember, these brushes will be connected to them. Let me put my resistor here. I'm going to put a bulb. So you can see now the brushes allows the induced current to flow to the outside circuit. So it allows the current to flow from the inside of the armature to the outside circuit. That is why I'm saying they are not intact. They are not actually fixed. Yes, that is the term that I was looking for. They are not fixed towards each other, to each other. So in that case, they are just in contact. In contact means they can move freely, but meaning that these branches must touch those ones. So when you look at this, here, these smaller circles that you see there, those are what we call the split rings. These are the split rings. And then now, how about the split? Split means divide. Split means divide. So in that case, I'm going to have something of this nature here. Alright guys, my drawing is not that perfect, but I'm trying my best here. I'm trying my best. You can see here the rings. When you look at the rings there, look at them. There is a split between them, meaning that that split there, it is the one that allows the current to the external circuit to flow in one direction. So the current that is going to be in the outside, I'm going to have the same thing here. I'm going to have my brushes. We now know what are the functions of the brushes. Then the brushes. I put my resistor there. So the difference between these two things, guys, is simple. Is that in here, the induced current or the current that is produced in here, when it reaches these rings, which we call the split rings, it is going to be allowing the current to the outside circuit to flow in one direction. That is why we call them what? The direct current generators. Are we together? But on this one, because there is no split amongst them, so the alternating current in the armature will proceed into the external circuit. So that is what the rings are for. These two rings are the ones that do what? Differentiate an AC generator to a DC generator. Are we together, guys? So what is the question then? The question simply says identify, or they like to put it like this: is this an AC or a DC generator? Where do you look for? Immediately you see that question, you run down to what? To the rings. You check the rings. Are the rings circle a complete circle? Yes, Therefore, that is AC generator. Are the rings splitted into two? Yes. Then that is a DC generator. That question, they like it, just to see if you are able to differentiate those things. Okay, now let us get now into the directions of this particular thing. The direction at first, guys, they seem to be a little bit confusing, but the moment you are getting into it, it becomes easier. All right. Now, what we know here is that the armature, this is the armature, this wire here which is folded like that is called the armature. The armature is going to be rotating in here. That means that is the direction of the rotation. And then we know that the magnetic field always moves from north to south. From north to south. How do I know that? I always claim it by going to south. People are going to South Africa. People are going to South Africa. So it makes me not to forget that. Alright, so we have the direction of the magnetic field, which is always known. If you are given, you know which poles that is. So if this is north, that is south, then we know they move from north to south. Okay, now if you check here, because this is a generator, electrical current is going to be produced. We know that because we said it takes the mechanical energy into the electrical energy. Alright, therefore, the current, the magnetic field, the direction of the rotation. How are we going to know these things? How are we going to find out now in which direction is the current going to move? Is it moving like this or is it moving like this? What did we say? How to predict the direction of the current? We said we use the right hand rule. We use the right hand rule. Alright, now on these three things, you are going to be given two of them. You will have to predict the third one. There's no way we can give you one and then you predict two. You must have two of them to predict one. So what do we have here? Now we know the magnetic field, the direction of the magnetic field. So let us put in another one then, the direction of the rotation. Let us start with, let's say, assume this, it is rotating clockwise. So the direction of rotation is indicated by clockwise and anti-clockwise. So we are going to be using that. Even if they say, what is the direction of the rotation? You must use clockwise or anti-clockwise, no any other thing. Okay, so this is clockwise. Clockwise. That is our clockwise. So what do we know now, guys? We know the direction of the magnetic field. We know the direction of rotation. Therefore, now we want to predict how is the current going to flow. Which direction is the current going to flow? Alright, now I don't want any one of you to panic. I don't want any one of you to panic here. Alright, this you're going to take your right hand. This is your right hand. I guess, yes, this is my right hand. This one, our thumb represents the direction of the rotation, the direction of the force. Are we together? This is my force, meaning that I will know up or down, but I will show you how to predict the clockwise and the anti-clockwise. Then this, I'm going to call it the fourth finger. The fourth finger represents the direction of the magnetic field. You can write them down so that you don't forget. I said this is the force. You see that? This is the magnetic field. You see here, I'm going to have my magnetic field. So, okay. Then the last one, which is the middle finger, is going to predict the direction of the current. Force, field, current. Force, field, current. Are we together there, guys? Okay. Therefore now, for us to predict the direction of the current, there are some few things that we need to actually emphasize. Now, we have two sides of my armature. To predict, we need only to focus on one side. Are we together there, guys? Okay, I'm going to choose this side. Let me call it XY, as they like to do that, XY. Alright, that is what we are having, XY. Now let us get into it. Let me get something to use as an armature. Alright, I'm going to use this thing here. Let me put my marker down here. This is your armature, guys. This is the armature. You can see it here. This is your armature. Let us look at that. Meaning that this point here is X, this point here is Y. Okay, now I want you to focus on the armature. Now, because your question paper will be horizontal like this, I want to bring it like that. So X and Y, when I bring it, it's like this. So when it is like this side, guys, it is still your X, this side, it is still your Y. So can you see X and Y? Let me do that again. This is my X, this is my Y. I'm taking my armature, I'm putting it horizontal. Alright. Therefore, now you have your armature, now you have your right hand. Now we are going to try and predict this direction of the current. Okay, to start is very simple. Let us, this side which I'm calling XY will always remain side XY. So let me explain what I mean. When you are looking at that, this is my right hand, if this is the right side, or just side XY. We focus only on this side, guys. Don't try to look at this thing, it's going to rotate. Now, they said the direction here is clockwise. I want you to look at this side. Forget about this side. I want you to tell me, what do you see on this side when this thing is rotating clockwise? Let us see. When I rotate it clockwise, this side here is going where? Down. Can you see that? It is going down. Okay, now you have it like this. We still focus on this side. And then this side is still my XY, meaning that don't say that your XY is going to come to the other side. No, this side is my XY. Let's see XY when we rotate clockwise. Let's see again. XY is that side. Let us rotate clockwise. Which direction is the XY going? Let us see that. You see that is going down there. It is going down. Now this side becomes XY. XY is going where? Down. So you can see this side of the armature always goes downwards. That is very, very important. And I need you to put that in mind. You can even look at this side. As I'm rotating clockwise, you can see this side will go up. You see that? Then this side will go up. So as this is continuing, this side is always going upwards. Is always going upwards. Can you see that, guys? Alright. Now we want to predict our current. I'm going to start again, X and Y. I'm going to put it here, X and Y, that is our side. So what do we know now? What do we know? We have to use our right hand, XY. This is my XY. Now, this is my north side. That is my south. Therefore, you have this. You are given this. You need to predict this one. Okay. Now, let me emphasize, this and this must be at the right angle to each other. Just try to make sure you can see here there is a right angle. I don't know if how am I going to put that. You can see here, this is my right angle. So you're going to try and put your fingers so that, look at this. This is my right angle. This is my right angle, so that they be at the right angle to each other. Are we clear there, guys? Let's get into it. Okay. Now, what is happening here? I'm going to start with magnetic field. Obviously, I like that. I can see my direction there. There it is. magnetic field. There it is. What is the force? We said we focus on one side. Again, this one side is going down. As this is rotating, this side is going down, down. This is down. When it comes back, this side still goes down. That is the direction of the force, or the direction of the rotation. Magnetic field, you can see north to south. Therefore, again, what do we have? The force really, this side is going down. Can you see, guys? Now, let us now open the middle finger. Where do you see? You can see that my middle finger is pointing from X to Y. Can you see that? Let us start that again. My magnetic field from north to south. Force, really this side here, down. When you are introducing fingers, you make sure that the one you started with do not change the direction. This must always point to that direction. My force is going down. Magnetic field is to the right. My force is downwards. Then let us look at the current. You see, I put my armature like this. Current is moving from X to Y. So in that case, it means already my current is going to move from X to Y. If this side is moving down, it means this side must move where? Upwards, isn't it, guys? Alright, let us see. Again, because we know the current must move like that. Now let us change the side. Because some people prefer to use the other side. So let us call this side AB. Side AB. We are anticipating side AB to do it, to go upward. The current should move from A to B. Let us see. I'm going to choose this side. This side now, when this is rotating clockwise, can you see this side, guys? When I try to rotate clockwise, you can see this side is going down, this side is going up. Can you see that? So that is my force. Force here is upwards. The magnetic field, I can see it there. It is to the right. Now, let us look at the force. The current. Current is the middle finger. I'm not sure if you can see it. But you can see now the middle finger is going from this point to this point. The middle finger is going from point B to point A, which is what we already have here. Can you see that, guys? So that is what we actually use the right hand for. I'm going to put that one down there. If you have any question, just put it in the comment below. So that you show me what do you want me to emphasize on. Okay. Therefore, now in that case, we are still going to be continuing with these two things. Now we want to get into the calculation part. The theory part is almost done. When you understand this, you already understand half of the questions. Okay. Now, the direct current and the alternating current. So let us get into the graphs. I'm going to take out the upper portion here. I'm going to take the upper portion so that I create space here. Alright, now what do we have? We are going to require the graphs of voltage. The graph of voltage in volts versus time in seconds or milliseconds, however you want to call it there. Okay, this is the graph of voltage versus time. Now, for the AC, this is the graph of AC generator. Okay. Now, what do we see here? The induced EMF, which is the voltage we know. As this is changing the direction, as the magnetic flux is changing the direction, what is going to happen, guys, is that the induced EMF is going to change the direction. So it is going to be somewhere at 0, then near at maximum, then near change the direction, and then it gives us something like that. So The point that you see here, it is the Vmax. That is our maximum voltage. Put that in mind, the maximum voltage. Now I'm starting to enjoy this thing, guys. The maximum voltage is called the Vmax. This one here, as you know, it is going to be called what? The V minimum. The V minimum. Why do we get a graph like that? It's from this, because this is doing what? It is changing the magnetic flux, meaning that the induced voltage, it is changing the direction. Are we together there, guys? Okay, now current and voltage follow each other. They follow each other. So meaning that if I draw the graph of current in amperes vis-a-vis the graph, vis-a-vis time, I'm going to get almost the same, not almost, exactly the same graph. Exactly the same graph, because the current is alternating. But in terms of the direct DC, in terms of my DC, this is what I am going to get. This is what I am going to be getting. Now, the DC, the induced one, or rather I'm going to focus it on the motors. Let me not use it as the DC, but the DC, let me just touch on it. I'm going to have the V into volts, time into seconds. This one, because the induced current, it is going to produce something of this nature. What do we get there? Because our current is not changing the direction. This is the direct. So current and voltage will actually have the same graph. So what do we have here? Because we are running out of time, guys, what do we call our graph of current and time, you can see there. Now, in most cases, you'll find that this will represent the one for motors, because the motors later again DC, meaning DC means that direct current. So in that case, we are going to have something like this. Are we together, guys? All right. Now, what I want us to focus on is this one. What I want us to focus on is this one. Let me remove this. Let me remove this, guys. Okay. What do we have here? What do we have? What do we have is we can see here, because we are having the alternating, you can see there that we have the minimum, the maximum. So if we want to get the what do we call it? If we want to get the average, if we want to get the average voltage here, we are going to say Vmax plus V minimum divided by 2. That is going to be by 0. So you cannot be able to charge someone on something that is 0. So in that case, what do we do if something is like that? We introduce something called power. We are going to introduce power. What do we know about power? Is that power is voltage multiplied by the current. Voltage multiplied by the current. Now, if we are going to take our two graphs, this first portion we can see our graph is what, guys? There, our graph is positive, and then our graph here of current is what? Is positive. You see that. So power says voltage multiplied by current. So let us take that again. Voltage multiplied by current. So this portion times this portion, meaning that we are going to get our new graph of power in watt, and then time in second. So this one times this one, it gives us a positive. Then we get to the second one, negative. This graph is negative. This one is what? Is negative as well. But power, look at power here, guys. Power is solving our mysteries. Negative times negative still gives us what? It gives us a positive. So our graph of power, even though it is alternating current, but the power gives us what? it gives us a positive values, which is very, very nice here, because when you look at this, we can now get the average, isn't it? We can get the average. Let us look into that. We are getting somewhere, guys. We are getting somewhere. This is the calculation part. I'm going to do some calculations with you here. You see, I'm going to show you how do we respond. You know, most of the learners, they have a lot of information, but they don't know how to respond. You are responding for marks, guys. You are responding for marks. So you must write things that are going to be giving you maximum marks. Okay. Now we have our graph, which looks like this. Now, what we are going to need here, we are going to need the P average. We are going to need the P average here, because this one we cannot get. The average is going to be 0, but the average power is not going to be 0, guys, because it's maximum, max, plus 0, then we will still have divided by 2, we will be having our average. So we are going to be having power is equals to the voltage multiplied by the current divided by what? By 2. Divide that by 2. Are we together? That is the average power. Okay. Let us work a little bit on this side. Let us work a little bit on that side. What do we have? What do we have there? I want to separate these two voltage and current. Now, if I say V multiplied by I divided by, let us break that into 2 portions. Someone can say 1 times 2. Okay, 2 can be get into when you say the square root of 2 multiplied by the square root of 2. So mathematically, if you say square root of 2 times the square root of 2, you will get what? 2. Meaning that I did not change anything there, guys. Can you see that? The square root of 2 times the square root of 2, it is still 2. Then what do we get here? We are now going to separate this. We are now going to say, let me separate this, and then let me separate that. What do you see there, guys? Now I can say I'm going to have V over root 2 multiplied by I over root 2. Mathematically, guys, we did not change anything. Are we together there? So you multiply this together, you will still get that. Okay, this is equals to what we have here. Now this is a square root of 2. We are going to give this a special name. We are going to call it the RMS, the root mean square. The root mean square. We call it the RMS, the VRMS, and as well as the IRMS. So this particular thing, we are going to call it now, it is going to be called the VRMS multiplied by IRMS. So VRMS is the same as saying the Vmax. Sorry, I forgot the max there. This is the maximum. This is the maximum. Remember, those are the maximums. Maximum. Alright. Meaning that now, what do we call this? We are going to call it the VRMS. This is a rectified voltage, the one that we are going to find on the appliances. So on the appliances, when they say your power is this one, your voltage is this one, we are talking about the VRMS. And then the power, we are talking about the average power. Are we together, guys? You will see that when we are doing questions. So what do we notice here is that the power average, the average power is equals to VRMS multiplied by the the IRMS. So what do we know from here? It means that if I want my VRMS, my VRMS is equals to the VRMS which is equals to Vmax divided by the square root of 2. That is a formula, guys. Where am I going to use this formula? Suppose you are given your graph like this. This is the graph of voltage. Again, here is power. Let's assume that this is voltage. You are given a value here. They say it's 300. And then we are saying to you calculate the VRMS. You are going to say VRMS is equals to 300 divided by root 2. Then you get your VRMS. The same thing as my IRMS is going to be equals to the Imax divided by root 2. Guys, you don't have to memorize those things. They are there in your formula sheet. I was just trying to show you how we are getting them and how we are using them. Therefore, this becomes the most important part of the calculation of this topic. Therefore, now, how do we do this now? How do we deal with this? How do we deal with this? We now know power is equals to, those V multiplied by I. Some they prefer power is equals to, is it V squared divided by R? Something like that. Let's see. Let us be sure. Iron is equals to V over R. Okay? So if you take this and you substitute it here, it is going to give you V squared divided by R. Okay, so this is now going to be V RMS. Then another one, you have your power is equals to the one which is current. Let us substitute our voltage here as I multiplied by R. We substitute it here. What do we get here? I times I, we will get I squared multiplied by R. Okay, so what I want to show you guys is that all the formulas for power that you know, where there is I, you're going to put is going to be IRMS. Where there is V, is going to be VRMS. Are we together, guys? I don't want to stress you too much with the formulas, because the formulas you are going to find them in inside the formula sheet. So this is what actually this topic is all about. You are going to be given some graphs. If it's a graph, the point here will be your V max, then you will be able to get it here. Your V max equal for V RMS. Then you work with that. I hope you enjoyed the lesson, guys. Anything that you need me to clarify, just put it in the comment section so that you can be able to get some more clarity on that. So for now, for this part, we are going to stop here. The second part, I'm going to be doing the questions with you. And with the questions, I like the questions because I want to show you how to respond. That is the most important thing, because I teach science at secondary. I see how the learners are not answering the questions correctly. You can see that the learner knows what to do, but the manner in which the learner writes is not going to do any justice to that learner. So in that case, guys, I hope you enjoyed the lesson, and I hope you understood, and I tried to make it better. Let me see you in the next video when we'll be doing the questions on this one.